Welcome Year 9 to this video. In this video I'm going to show you how to factorize quadratic trinomials, a special type of quadratic trinomials. We'll start off with the really basic ones, and then another video I'll look at the harder ones, and I want the girls who are going on to do pre-methods mathematics next year, I would like you to do that extension stuff, but for everyone else I'd like you to just focus on this particular video here when we factorize quadratic trinomials. Now before I begin, I just want to explain a couple of things before we start, because I mean when I just throw around these large words here without explaining what they mean, I think we get lost a little bit. So first of all, when I say quadratic, what I'm talking about is in the expression that we're given, so for example the one below is a quadratic trinomial. To make it a quadratic, or the definition of the quadratic, means that the variable, which is x here, the highest power that it will be raised to is a 2. So the highest one that we'll see, the highest index of the x term will be a 2. There'll be no, say, x to the power of 3 or x to the power of 4. There can be x to the power of 1, which is what we've got there, but the highest power is just the 2. Okay, by trinomial, I mean that there are 3 terms in the expression. So as we can see here, we have 1 term, 2 terms, 3 terms. Okay, now the particular trinomials that I will look at in this video are where this value here, the coefficient before that x squared term, this one here, will be equal to 1. So we'll say a equals 1. These are known as monic quadratic trinomials. So what this means is when we have our expression, I can rewrite this here, it will look like this. So we will have a number in front of the x and we'll have a number at the end there. We'll have a c value as well. But there won't be a number in front of this x squared. Well, there is a number there, it's a 1, but of course we don't write that. So this is what we're going to factorize. They will look similar to this one here, but with the numbers in there obviously. Now we're going to use a special method that's called the, well, some people call it this, I call it this, the sum and product method. And I want to show you where this comes from, why it works. And how I'm going to do that is just with an example, first of all. Now these here, they will factorize into 2 brackets. So you might remember when we had 2 brackets and we were doing expanding, we expanded things that looked similar to, say, this one here that I'm going to write down, x plus 2, x plus 3. And when we expand, hopefully you can remember this, we use this little thing to help us guide us through the process of expanding. So we do first terms, then the outside terms, then the inside terms, then the last terms. Finally, we simplify. So let's expand this one and see if there's any pattern that we can find within this. So this is the expanded version, and this is a factorized version. When it's factorized, we'll have the 2 brackets. So what would it look like if we expanded it? Well, first term's x times x squared. Then we would do the outside term, so x times 3, and it's a plus 3, so it makes it plus 3x. We then do the inside term, so this would be plus 2x. And finally the last term, so that would be 2 times 3. I'm going to write it as 2 times 3. Okay, now finally, to simplify, what I would do is collect like terms. And as you can see, I've got an x term here and I've got another x term there. So this would be 3 plus 2x, so it would be 5x. But just for the moment, I'm just going to write it like this, just so I can show you where our sum and product method comes from. Okay, now when we factorize, really what we're doing, whenever we've got just a 1 out the front here, it means that this term, the first term in the 2 brackets, is always going to be just x, because to get x squared as our first term when expanded, we couldn't have any other numbers here. If we had, say, a 2 at the front, that would be 2x times x. That would be 2x squared. So, of course, whenever we've got the monic quadratic, so just a 1 out the front of this x squared term, the two first terms in our bracket will always be just x. So really what we're focusing on is what are these other two numbers? To factorise these, that is our sole focus. What are these other two numbers that we put in here? And this is how we can work it out. So have a look at here. The c term is going to be 2 times 3 in this example. So that's that number there multiplied by that one. So this term here, that's our c term. Now if you have a look at the middle term, that is those same two numbers, but instead of being multiplied like they are here, they're being added together. So this is our b term. So the c term are the two numbers, so I'm talking about these two here, two numbers multiplied together give the c value, so that number at the end. The two numbers within this bracket here, the two ones that come second, they must multiply to give me c. Those same two numbers, those exact same two numbers at the end there, they must add together so they must sum or add, means the same thing, to give the b term, to give that number here. I've just made that very messy, but anyway. So hopefully you can see 2 times 3 will give me the c, but adding those together instead, so 2 plus 3 or 3 plus 2, that will give me the b term. This is where the sum and the product method works really, really well. Let's have a look at just this example here. Just summarizing this sum and product method in a way, using some numbers now. So our first step whenever we use this method is to have a look at the expression, and my focus to begin with is going to be on this term here. It could be positive, it could be negative. This one is a positive one. So I need to think of two numbers that multiply together to give me 6. Therefore I'm looking for the factor pairs of 6. So whenever you've got a number, you can always use the number itself and 1, can't you? 6 times 1 would give me 6. Unless it's a prime number, you should have another pair as well. So I know this one, I can use 3 and 2. Now you can write these down, or you can just think about them in your head. You don't have to write them down. So when I multiply these together, I will get 6, which is what I need. But those same two numbers that I pick, that pair of numbers, for it to work within this factorization, they have to add up to this number here. So I now focus, once I've got my factors, I now focus on this number, and we can see it's positive 5. So looking at the two pairs that I had for 6, do any of these add up to 5? Yes, they do. 3 and 2. Because, like right under here, 3 plus 2 equals 5. So these are the two numbers that I've been looking for. So when I factorize, I start off with my two brackets. I put my x term first, because I know that x times x is x squared, and that's what is shown here. The two numbers are 2 and 3. Whoops. Plus. As they're both positive, we should have a plus here. And that is the factorised version of x squared plus 5x plus 6 is the same as 2 brackets x plus 2, x plus 3. So if you expand this out now using FOIL, you will get that expression that's written up the top there. Okay, let's have a look at some more examples. Here we go. Start right up the top here. We have x squared plus 3x plus 2. So two numbers that multiply together, so the product that gives 2. So there's actually only 2 available. 2 is a prime number, so we've only got 2 times 1 that will work here. Okay, so 2 times 1 is 2. They need to add together to give 3, and they do. So these are our two numbers. We start off with writing our two brackets. We put an x at the front, and our two numbers are 2 and 1. Now, it doesn't matter if you put the 1 first and you put the 2 second, it will be the same. So it's the same as this here. Both answers are correct. Why are they correct? Because it's multiplication. So, for example, 7 times 7... I need to pick different numbers. 7 times 6 equals 42, and 6 times 7 equals 42. Okay, so the order of the multiplication, it doesn't matter. That's handy to know when you're checking your answers. If you see yours is written in a different order, don't worry, you still have it right. Okay, let's do the next one. So, we need two numbers that multiply together to give 4. So I could have 4 and 1, or I could have 2 and 2. They also need to add together to give 5. So 2 and 2 is 4, so that one doesn't work. But 4 plus 1 is 5, so this works. Our two numbers are 4 and 1. And that is now factorised. Alright, let's have a look at this one here. I'll just have to move my colours out of the way. We want two numbers that multiply together to give us 9, but add together to give us 10. So we could choose, say, 9 and 1, or we could choose 3 and 3. 3 and 3 is 6, so that doesn't work. 9 and 1 is 10, so that one works. So x plus 9, x plus 1. Okay, moving along, this one here. So we've got a 9 again. So 9 and 1 is an option, or 3 and 3 is an option. Okay, this one here, a little bit different because now we have a negative here. So this means that the two factors that we choose may have negatives in them. Now let's first look at the last number. We've got positive 10. Okay, so for 10 I could have 10 and 1. I could have 5 and 2. Now, when I add these together, I actually need to get a negative number. When I add these two numbers, I have to get a negative 11. Now, if you look at this, when they multiply together, it must be positive because my C value is positive 10. So what that tells you, well, that hopefully tells you, is both of these numbers must be negative. Now, if I had, say, negative 5 and negative 2, multiplying them together does give me positive 10, but negative 5 minus 2 is negative 7, so that one doesn't work. Let's try this one here. Negative 10 minus 1 is negative 11, so this one works. Now, why do I say negative 10 minus 1? That's because negative 10 plus negative 1 is negative 10 take 1. So hopefully you are a little confident with, you do need to be confident, I should say, with your negative numbers, adding them together. Okay, so where was I? X and X. My two numbers were negative 10 and negative 1. Two negative numbers, when you multiply them together, remember, make a positive. All right. Couple more to go here, and yes, we've got some negatives in here just to make it a little bit more challenging. All right, we have positive 10. So again, just like before, I jot them down first, but I notice here I've got a negative. Now, I cannot have two positive numbers that add together to give me a negative number. So again, this indicates that both of these need to be negative. They've got to multiply together to give positive, but they've got to add together to give negative. So which one works? This one here gives me negative 11, but this one here, negative 5 take 2, is negative 7. So this one works. x take 5, x take 2. My two numbers. Okay, so this one here. Now, I actually have two negatives this time. My c value is negative, and so is my b value, that middle term, the coefficient of the middle term. So, factors of 20. Well, we'd have 20 and 1. We've also got 5 and 4. Okay, so I need these to get to -1, and when I multiply them, they have to be negative. So that means that one of them needs to be negative, not both. I can't have both of them negative, so that would give me a positive c. So 1 must be negative, and when I add them, I've got to get -1. So what if I had -5, +4? -5 plus 4 equals -1. So this works. If I did it the other way, if I did -4 plus 5, that is +1. So that does not work. So this is what I'm going with, -5 and +4. How do I write that? Just like this, x minus 5, x plus 4. You can check it, -5 times 4, that is -20. And then if you did FOIL on that, you would get -x. Okay, so this one here, we've got -24, +5. So two numbers that multiply together to give me the -24. Now, 24 does have quite a few factors, doesn't it? So we've got 24 and 1, obviously. We've also got 12 and 2. We have 8 and 3. And we have 6 and 4. So lots of options here. Now, when I add them together, they've got to get to +5, and one of these numbers needs to be, one of the numbers in the pair needs to be negative. Now, look at the difference between 24 and 1. I'm not going to get 5, am I? I'm going to cross that one out. Just like 12 and 2, the difference between them is 10, so I'm never going to get to 5. 6 and 4 is not going to work either. 8 and 3 looks promising. If I have, I need it to be a +5 when I add them together. So I'll take the larger number being positive and I'll make the smaller one negative. This would be 8 minus 3, which is 5. So you can see that there are a few logical ways of thinking about it, but if not, you just have to test them out. If you're struggling with it, you do just need to try it out. I mean, you could, as soon as you see, say for 12 and 2, you can see they're going to add together to give 14, and you can see if you take 2 from 12, you're going to get 10. You're just never going to get to that 5 that you're wanting, so you need two numbers that are closer together. Alright, so we've got that one there. I know there are quite a few examples in this video here, but I think it's very helpful to see quite a few different examples of this, because as you can see, the different combinations of negatives and the different numbers that you come across and the range of factors is quite large. So lots and lots of practice with these, please. Pause wherever you wish if you need to jot these down for future reference, but otherwise we're going to have a look at just some final examples of something we might come across. Now, I know I promised that all the ones that we come across will have a 1 in front of this, and these ones here do not have a 1 in front of them, as you can see. But it doesn't matter, because there is a little trick that we can do that's going to help us. It's actually going to make that x term a 1 after we do this first trick. And that trick is to check for a highest common factor, the HCF. Now, one thing that you should be able to see whenever you get one like this is this number at the front is going to go into those two terms. We check it first. We've got a number 3. Does 3 go into 9? Yes. Does it go into 6? Yes. So it means we have a common factor in all of these terms. It means we can take that common factor out of the bracket. This is what we're left with. As you can see, what's left in the bracket here is now a monic quadratic trinomial. So I'm going to be able to factorize this exactly like I did on the previous page. I'll leave the 3 out the front. That's got to be there. Okay? Don't leave that out in your final answer. two numbers that multiply together to give me 2, but add to give me 3. And there we go, that is factorised. So the only difference is we have this number out the front being multiplied. But once you take that out of the expression and you're left with this part in the bracket, it's just about factorising what's left there in the bracket. Okay, I'll do this one on the right. Let's have a look. This number out the front. You should always be checking whether this number here goes into these two terms. And it does. 4 4s are 16, 4 3s are 12. Okay, so let's take that out. Oops, don't write the 4 again. You just want the x squared now. Don't forget about this negative here, because 4 by negative 4 would give me the negative 16. And then we've got plus 3. Okay. So, two numbers, they multiply together to give me positive 3, but they add to give negative 4. So they must both be negative. So 3 is prime, so we'd only have one factor pair to examine. That would be 3 and 1. They've both got to be negative to give me negative 4. There we go. Last two. Oh, 3, sorry. There's one hiding. All right, so let's check this number here. It's a 2. 2 goes into 10 and it goes into 12 as well. So let's take it out so that our number in the front of the x squared now is a 1. Okay, don't forget your 2. We want our 2 brackets and we want our 2 numbers that multiply together to give 6 but add to give 5. So the very first one we did look like that. Next one, we've got a 5. Does it go into 40? It does. Does it go into 60? It does. So let's take it out and let's see what is left. 5 8s are 40 and 5 12s are 60. Don't forget your negative. Always check for those negatives. Okay, 5 is left out the front. 2 brackets, x, x. Now we've got a 12 multiplied together to give 12, but add together to give 8. So what have we got? 6 and 2, 12 and 1, 4 and 3. So I need 8. I can see these two here have a difference of 8. And now they've got to be, it's got to be positive 12 when we multiply, but it's got to add to give me a negative number, so they both must be negative. X minus 6, x minus 2. Okay, one more to look at now. And this one is a little different because we've got a negative out the front. We've got a negative out the front of this x squared. We actually can factorise this, even though this is not a 1, it's a negative 1. What we'll do is we'll actually take highest common factor out of negative 1. Now, whenever you take a factor of a negative factor out of a bracket like this, what's left inside will be the same terms, but they'll have a different sign. They'll have the opposite sign. Now, what I mean by that is if it was negative in the original expression, after it's been factorised, after a negative 1 has been taken out, it should be positive. When it's negative in the original, it needs to be positive. If it was positive in the original, it then needs to be negative. Now, when if we were to expand this, this would be negative x squared minus 7x minus 10, and that's what we have there. Now that we've done that, we don't have to write negative 1, we can just put negative, 2 brackets, 2 numbers. For 10, we'd use either 10 and 1 or 5 and 2. They've got to add together to give me 7, so I'm going to use 5 and 2. And you must put your negative out the front there because we've taken it out as a common factor. So there's a lovely little trick. Whenever you see that negative out the front of your x squared, take negative 1 out as a common factor, change the sign of everything that's left. So everything inside the bracket should have a different sign to what it had in the original expression. And then once we've got that, the x squared term has got a 1 in front of it, so we can factorise using that sum and product method. Okay, I'm sorry, this is quite a long video after all that, but it does have lots of examples, which is really, really essential to get good, fluent, I guess, with this skill. It's a really important skill for this topic, so I do urge you to practice with this as much as possible. We'll have a look at this a lot in class. We're going to be doing lots of factorising, especially when it comes to solving as well. So thanks very much for listening to this, and good luck.